Now that we know how to add polynomials, subtract polynomials, and also multiply polynomials, the next natural step would be to divide polynomials. We'll begin with how we divide a polynomial by a one-term monomial. And before we do that, let's remember how we add fractions. This will make sense in just a moment because this will help us learn how to, believe it or not, divide a polynomial by a monomial. So just go with me for a moment. How do I add 2 7s and 3 7s? We are adding fractions. The denominators are the same. So remember, we keep that common denominator, and in this case, we add the numerators. So we have 2 plus 3, or 5 7s. It's true that 2 7s plus 3 7s is 5 7s. In general, then, can you agree with me that, let's say, the fraction a over c, and of course c is not 0, we don't want the denominator to be 0, plus b over c, that is what then? The denominators are the same, so I keep that common denominator, and in the numerator we have a plus b all over c. A plus b all over c. Now, what if I read this from right to left? A plus b all over c is equal to a over c plus b over c, and that will help us then learn how to take a polynomial and divide by a one-term monomial. Let's look at the following. So this is dividing a polynomial by a monomial. We divide each term of the polynomial by the monomial. In other words, a plus b all over c is equal to a over c plus b over c, as we talked about a moment ago. Let's try that with the following. Notice here we have a polynomial. In fact, in the numerator we have a binomial, and we are dividing, the fraction bar means division, we are dividing by a monomial. That's one term. So how do we do this? We write each term in the numerator over that term in the denominator. So this is equal to the first term, 12x to the 4th over x, plus the next term, 3x squared over x. We have now divided, but let's simplify. And we simplify as usual using our rules for exponents. We have 12. And then what is x to the 4th divided by x, or x to an understood power of 1? Remember, we subtract exponents, so this is x raised to a power of 4 minus 1, or 3, plus, here I have 3, and this is x raised to a power of 2 minus that understood 1. 2 minus 1 is 1, so I can write this as 12x cubed plus 3x. That is the quotient when I divide this binomial by this one-term monomial. Let's look at another example, and it will be the same thing. Notice I've got a polynomial, negative 9x to the 5th plus 3x to the 4th minus 12. This happens to be a trinomial in the numerator, and I am dividing by a monomial. Let's try the following. We have a trinomial in the numerator divided by a monomial. So how do I do that? I write each term in the numerator over that one term in the denominator. So I have negative 9x to the 5th over that term in the denominator, 3x cubed. Next term in the numerator, plus 3x to the 4th over 3x cubed, that monomial in the denominator, and then we have minus 12, the last term in the numerator, over 3x cubed. I've divided, now let's simplify. And we use rules of exponents to simplify. Negative 9 divided by 3, well, that is negative 3. And then notice I have x to the 5th divided by x cubed, so that is x raised to a power of 5 minus 3, or 2, plus 3 divided by 3 is 1. And then I have x raised to a power of 4 minus 3. Because we are dividing, we subtract exponents, and 4 minus 3 is 1. Minus 12 divided by 3 is 4. Now that's 4 in the numerator, and then I have x cubed in the denominator. This is fine, or if you'd like, you can write this as negative 3x squared plus, I can write that middle term as simply x minus 4 over x cubed. That is how we divide a polynomial by a monomial. Let's now talk about dividing a polynomial by a polynomial other than a monomial. So dividing a polynomial by a polynomial of 2 or more terms. To do that, let's see how we long divide. Let's recall that by dividing 8 into 763. How do we perform long division? Well, we say 8 divides into 76 9 times. 9 times 8 is 72, and then don't forget we subtract. I'll bring that up again in a moment. I'll draw my line and we subtract. 76 minus 72 is 4. Then remember, we bring down the next digit, in this case a 3, and then we start the process again. 8 divides into 43 how many times? That is 5. Then we multiply. 5 times 8 is 40. I'll draw my line, but don't forget we are subtracting. 43 minus 40 leaves us a remainder of 3. So what is the quotient? Well, the quotient is 95 remainder 3, or don't forget we can write this as 95 and 3/8, the remainder over the divisor. Keep that in mind because that's how we will long divide polynomials. So let's practice that. Let's look at x squared plus 4x plus 3 trinomial divided by a binomial. Notice once again, this is a trinomial divided by a binomial. That means we will long divide. I'm no longer dividing by one term or a monomial. So let's practice this by long division. This is the divisor, so it's x plus 3 into, this is the dividend, x squared plus 4x plus 3. Now let's practice that long division just like we long divided a moment ago. You can say x divides into x squared how many times, or you can say what times x gives x squared. Either way. Well, in fact, I know x times x gives x squared, so let's now multiply. I'm multiplying x times this divisor. X times x is x squared. X times 3 is 3x. Then don't forget, just as before, after we draw our line, we are subtracting. To remind myself that I'm subtracting, I will change each of these signs to remind me that I'm subtracting. So I have x squared minus x squared, that's 0x squared or 0. 4x minus 3x is 1x or simply x. And then bring down the next term, just as before. Now, what times x gives x? Well, 1. So I'll write down plus 1, and then we multiply. 1 times x is x, and then 1 times 3 is 3. I'll draw my line. Don't forget we are subtracting, so I change the signs of each of the terms of this polynomial to indicate that we are subtracting. X minus x is 0, 3 minus 3 is 0. We happen to have a remainder of 0. What is the quotient then? The quotient is x plus 1, and how can we check? I'll let you check, but multiply x plus 1 times the divisor x plus 3. That product should be that dividend x squared plus 4x plus 3. Let's practice long division of polynomials. Why am I long dividing? Because the divisor is 2 or more terms. So again, long division. The b plus 4 is the divisor. This is the dividend, so I'll rewrite it. 2b cubed plus 9b squared plus 6b minus 4. By the way, notice the divisor has no what I'll call missing powers of b. This is b to the 1, and we can think of that as b to the 0. And the dividend has no missing powers of b. b cubed, b squared, b to the 1, b to the 0, or simply a constant. I'll bring that up again later, but for now, let's long divide. So how many times does b divide into 2b cubed? Or if you'd like to think of it this way, what times b gives 2b cubed? Well, I know 2b squared times b gives 2b cubed. Now we'll multiply 2b squared times the entire divisor of b plus 4. So that's 2b squared times b, which is 2b cubed, plus 2b squared times 4, and that is 8b squared. And notice our like terms are naturally lining up, and they will when there's no missing powers. I'll draw my line, then I'll change the signs here because I'm subtracting. Here I have 0. 9b squared minus 8b squared is 1b squared, or simply b squared. And then I'm going to bring the rest down so that I don't lose any of my terms. And let's do this process again. What times b gives b squared? That's b. Now I'm multiplying b times this entire divisor. So b times b is b squared plus b times 4 is 4b. Very, very important. Do not forget, once you draw your line, you are subtracting, so we want to change these signs. B squared minus b squared is 0b squared, or 0 like we want. 6b minus 4b, that is 2b. And then I'm bringing down my minus 4. So let's keep going. What times b is 2b? That is 2. Now I'm multiplying 2 times this binomial. 2 times b is 2b. 2 times 4, that's plus 8. Still, do not forget to change those signs. We are subtracting now. Make that a minus and that a minus. 2b minus 2b is 0. Negative 4 minus 8, that is negative 12. I have a remainder this time. So what is my quotient? My quotient is 2b squared plus b plus 2. Then we will write this as a fraction, just as we did when we first long divided. I can always write it as plus this remainder, negative 12, over the divisor of b plus 4. By the way, if you're wondering, since this is just one term, can I just make this minus and make this 12? Absolutely fine. Either way is perfectly okay. But here is my quotient then, and I've long divided. We are now going to long divide. I'm dividing by a binomial x minus 3. Notice for this division, we do have some missing powers of x in the numerator or the dividend, however you want to think of it. Now this is the divisor, so I'll go ahead and write down x minus 3 into, I'm going to go ahead and fill in those missing powers with a coefficient of 0. In other words, x cubed. The next power, if I decrease each time by 1, would be x squared. So I'll write 0x squared plus 0x minus 27. Do you have to do this? No, but you've got to be really, really careful with lining up like terms if you do not. All right, so I'm going to suggest you do it this way. Make sure your divisor and your dividend have no missing powers of your variable. Now let's divide. What times x is x cubed? That's x squared. Now we'll multiply. X squared times x is x cubed. X squared times negative 3 is negative 3x squared. And see how this naturally then just lines up. Our like terms line up. Draw your line. Do not forget you are now subtracting, so we change the signs. So that's 0. I have then 0x squared plus 3x squared. That is 3x squared. And I will write my other terms down so I don't lose them. Let's do the process again. What times x is 3x squared? That is 3x. 3x times x is 3x squared. 3x times negative 3, that's negative 9x. Draw your line. Don't forget to change the signs. That's 0x squared like we want. That is 0x plus 9x, which is 9x, minus 27. And now what times x is 9x? That is 9. 9 times x is 9x. 9 times negative 3 is negative 27. Don't forget to change the signs, and I have a remainder of 0. So my quotient is x squared plus 3x plus 9. The best advice I can give you when long dividing polynomials is to make sure you write neatly and line up those like terms. And you can check by multiplication. So how do you divide now? If you divide a polynomial by a monomial, you simply write each term of the polynomial over that monomial and you simplify. If you're dividing by a polynomial of 2 or more terms, like we did here, try long division. Let's check your understanding of dividing polynomials by answering the following question. Divide the following: 3x squared plus 6x all over 3x squared. Once you divide, is the result A, 1 plus 2 over x? Is the result B, 3x squared plus 2 over x? Or is the result C, 1 plus 6x? The video will stop. That will give you time to go ahead and divide and then make your selection. A is the correct choice. Let's see why. We are dividing by a monomial, so this is the first term, 3x squared over 3x squared plus 6x over 3x squared. This simplifies to 1, and this, 6 divided by 3 is 2. X over x squared, there's an extra x in the denominator, so we have 1 plus 2 over x. Choice A is correct. Choice B is not the correct choice. Let's see why. We are dividing by a monomial, so this is equal to the first term, 3x squared over 3x squared, plus the second term, 6x over 3x squared. This simplifies to 1, not 3x squared. This is incorrect. The correct choice is choice A. This simplifies to 1, plus this does simplify to 2 over x. Choice C is not the correct choice. Probably what happened was you looked at 3x squared over 3x squared and wrote that as 1, but still you have 6x over 3x squared. In other words, correctly, this becomes the first term, 3x squared over this monomial in the denominator plus 6x over 3x squared. This is 1, but this is 2 over x. That second term simplifies as 2 over x. The correct choice is choice A, which is 1 plus 2 over x. C is incorrect, A is correct.